Hello everyone and welcome back to a calculus video. So in this video we're going to start talking about extrema. And extrema are extreme values. So we're talking about minimums and maximums of a particular graph. So let's dive into the definitions. So we have an interval I containing the value c. F of c, remember this is the y value, so the y value at c is a minimum of f on this particular interval when f of c is less than or equal to f of x for all x in the interval. So all that's saying is that we have this graph here, and maybe our graph looks something like this, and we have a minimum here at c. What that's saying is that this y value, which is just f of c, has to be smaller than all of the other y values along that graph on whatever interval we're talking about. So we could talk about the interval here from 0 to this point. I'll just call it x. So in this interval, you can see that that y value would be smaller than anything else, and that's why it's called a minimum value. So likewise, let's talk about maximum. F of c is the maximum on f maximum of f on the interval I when f of c is greater than or equal to f of x for all x and I. So let's draw a picture of what this is trying to describe. So maybe we have a graph that, I'm just going to keep it simple, quadratic, looks like this. Here we see a maximum. Remember, a maximum is just a high point on the graph. A minimum is just a low point on the graph. So we're talking about that maximum here. Here's the c value they're talking about. F of c is the y value. And all this is saying is that this y value has to be bigger than all the other y values on some particular interval here. So if we're talking about the interval, again, from maybe this point here to this point over here, which would be down here, then you could see that this is definitely the biggest y value. Now, we could also talk about the minimums on a closed interval, or we could talk about absolute min and max. So notice that they haven't really talked about what interval I is. So it could be the entire domain. It could be a small interval from A to B, or it could even be a closed interval from A to B. Now, if we're talking about the highest point on the graph or the lowest point on the graph, then we are talking about absolute mins and absolute max. So, like for this example over here, the lowest point of the graph is happening at this value here. So we would say that is an absolute minimum for that graph. Likewise here, this is the highest point on the graph. So that is the absolute maximum. So anytime you're talking about the highest or the lowest, that's always going to be absolute. But we also have this idea of relative extrema. And all relative means is it is a high point or a low point on the graph. So it doesn't have to be the highest, it just has to be the biggest in some kind of open interval. And that's what this definition is referring to here. So a good example would be something like this guy. Let's say we're looking at its entire domain, which would be all real numbers. We have a high point here on the graph, so this would be a relative maximum. And then we have a low point down here, which would be a relative minimum. So all that means is that this point is lower than anything else around it, but it's not the lowest point on the graph because this thing keeps going down to negative infinity. So it's not absolute, it's relative. Relative means on some kind of small interval around this guy, it is the lowest or the highest point on the graph. So sometimes instead of using the word relative extrema, you'll see them talk about local extrema. So those are used interchangeably. Now, what if we are talking about a closed interval? Well, it turns out if we're talking about a closed interval of a graph, then we will have both a minimum and a maximum value that's going to happen. So let's think about just a picture here. So let's say we have a picture. Maybe I go back to that cubic that looks something like this. And let's say I'm talking about the piece of the graph here between A and B. So there is my f of A point. Here is my f of B point. And you can see that this is going to have a graph. And not only it has a max. Not only does it have a max, but it is an absolute max occurring at whatever this y value is, because that will be the highest point in that particular interval. Also notice that we do have a minimum, and that's happening right here. And that's an absolute minimum on that closed interval from A to B. So essentially what the extreme value theorem says is that if you have a closed interval, you're guaranteed a minimum and maximum. You're actually guaranteed an absolute minimum and an absolute maximum, all because you're looking at a very small piece of that graph. But that's only guaranteed if we're talking about a closed interval there. So it's important to note that. That's got to be closed. Now, how would we go about finding extrema? Could we use calculus to do that? And the answer is yes, we can use calculus to do that. So if you think about the definition of a derivative, derivative gives us the slope of a secant line, a tangent line. And if we're talking about some graph and we want to know local extrema, local extrema happen when we have a turning point. So we either go from increasing to decreasing, creating a maximum, or we go from decreasing to increasing, creating a minimum. So, and anytime that happens, you're going to have a horizontal tangent line. So really, extrema in general occurs when we have a horizontal tangent line, which means that that derivative has to be equal to 0. And that really is the definition of what's called a critical number. So if we find the derivative and we set it equal to 0, that tells us where we're going to have this critical number. Now, how do we know if we have a minimum or a maximum? Well, we're going to look at what's called a sign chart. And we're going to look at the slopes of the tangent line. And we're going to do a sign chart for the first derivative. If we're increasing and then we decrease, so we increase here and then we decrease, every time that happens, we're going to have a maximum. So our sign chart would look something like this. We would be increasing, then decreasing. This has to be a maximum value on the graph. Now, if we are decreasing and then increasing, our sign chart would look like this, decreasing and increasing. And anytime we decrease then change the increase, we're going to have a minimum on that graph. So we'll be able to use the slopes of the tangent line and the derivative to tell us whether we're increasing or decreasing. Now, it turns out that relative extrema can only happen at critical numbers. And we're talking about local extrema here. Because we just saw before that if we're looking at a closed interval, then we could have extrema at endpoints. But in general, if we're talking about a function on its entire domain, then extrema is only going to happen at critical numbers. So let's look at a few examples. Let's say we want to look at a function. Maybe we want f of x equals 4x squared minus 6x. And we want to know where's the extrema. We're going to start by taking the derivative. So we have 8x minus 6. And then we're going to set that derivative equal to 0. Remember, we're looking for horizontal tangents here. Now, we know a little bit about this graph already. It's a quadratic and it opens up. We don't really know anything about placement on the xy plane, so I'm just going to draw it like this. But we know we've got a minimum value just based on, we know it's a quadratic that opens up. So let's find where that's going to happen. That's where we take the derivative, set it equal to 0, and then we're going to solve it. So that minimum is happening at x equals 3 over 4. Now, what we have to do is put this on a sign chart. And then we're going to test. So this is our sign chart. We want to know about the slopes on the left and on the right of 3/4. So I'm going to substitute in something on this side of the graph. I can substitute in 0. 0 is to the left of 3/4. And it goes into that first derivative. So I have 8 times 0 minus 6, which is going to give me a negative number. Now, it's going to give me negative 6. I don't really care what the value is. All I care about is that it's positive or negative. In this case, it's negative. So now let's substitute in something bigger than 3/4. I'm going to substitute in 1. So I'm going to have 8 times 1 minus 6, which is going to give me a positive. So what that tells me is this graph is decreasing and then it's increasing. So if I'm decreasing then increasing, this has to have a minimum at 3/4. Now, if we want the y values always come from substituting into the original function. So I'm going to substitute my x value in. And I'm going to get negative 9 over 4. So my point, my ordered pair, would be 3/4 negative 9 over 4. So that's how we would go about finding extrema.